A building is a very complex system, influenced by a wide range of parameters. Hence, designers have traditionally found it cumbersome to assess the overall building energy performance and to size building components and systems with reasonable accuracy through conventional methods such as using rules of thumb or the expert advice of equipment suppliers. Fortunately, with the rapid progress of computer applications, we now have many software tools that are assisting designers to predict and analyze the energy performance of a building at the design stage with good accuracy and with substantial reduction in effort. As a result, it is possible to analyze the building's key performance indicators and make appropriate modifications in the design before the building is constructed. Sensitivity analysis of various design options and decisions is very useful from the conceptual and schematic phases to the detailed specification of building components and systems. An energy simulation program is used in the same way whether one is designing a new facility or making improvements to an existing facility. In both cases, the first step is to input the characteristics of a baseline facility configuration. For the program to calculate loads and energy consumption with a reasonable degree of accuracy, one needs to describe the facility and its systems in sufficient detail. This is a critical and important part of the process and requires experience, subject matter expertise, and computer skill to model the building accurately. Once this is done, one can easily modify the inputs and rerun the program to simulate the impacts of the modifications. The sensitivity analysis involves changing a single input over a range of possible values to determine the effect of the variation on the overall output. Sensitivity analysis tends to be neglected, resulting in projects that fail because actual conditions differ from those expected. It is important to conduct sensitivity analysis for each input which has some degree of uncertainty and which is likely to have a significant effect on performance. Sensitivity analysis increases the computation time but helps in optimizing design. An energy analysis program cannot precisely simulate the wide variety of building shapes, equipment, controls, and conditions that exist. Energy analysis programs differ in their strengths and weaknesses. It should be ensured that the program chosen is able to simulate the architectural and engineering features that are important for the project. When selecting an energy analysis program, consider both the features of the program and the support that will be available for it. Some of the key features to consider include simulation capabilities, ease of inputs, library of data, output options, and technical support. Architects, civil engineers, mechanical or electrical engineers with solid building physics background and basic understanding of lighting and air conditioning systems are good candidates for learning energy simulation programs. To start with, it is good to use very simple software that allows to understand the different aspects of building design. For example, there are specialized computer tools to analyze the climate and its impact on the indoor environment. Some tools allow to study the movement of the sun for a given construction site and its impact on the building. Others include computational fluid dynamics as a sophisticated airflow modeling method to design thermally comfortable, healthy, and energy efficient building by predicting airflow, heat transfer, and contaminant transportation in and around the buildings. While most simulation tools quantify the energy savings and energy cost savings, it is important to know the real costs involved in achieving those savings. Such an analysis provides more confidence to the potential builders regarding both the costs as well as the tangible benefits that can be accrued from specific features adopted in a building.